Hello everyone, this is Bharat Singla, a class 10 student and a 5-star coder on CodeChef. Today we'll be discussing the problem division with the code DIVEO from October's first starters. Difficulty I would rate simple to easy, and there are prerequisites. There is prime factorization, which you should already know. If you do not know about it, there is a playlist on that as well, and I had created it myself. So you can maybe just search up Bharat Singla prime factorization CodeChef, and you can, after watching that, come here if you do not know about it yet. Great. So let's have a look at the problem. Cool. So you are given an integer n, right? You repeat an operation until n becomes 1. What you do is just pick any number which is a divisor of n, change n to n by x. So basically divide n by any number if obviously that number is a factor of n. Fine. So if x was even, you get a points. If x was odd, you get b points. Find the maximum points you can get if you perform the operations optimally. So, okay, this problem actually isn't that simple, right? But it is actually simpler than it seems. Now, the reason why I make this statement is because there's a very well defined thought process as to how you should approach the problem. There's like a guided path on your approach, your thought process. So, as soon as I saw the problem myself, I kind of knew what I had to do. And that's basically what I'll brief now as well, is that because we are dividing n by some numbers and we are trying to do it optimally, it's obvious that we'll have to find the prime factorization of n because we are dealing with divisors and all, right? Obviously better to have the prime factors of n. And then notice that there may be few even prime factors, few odd prime factors, right? But because a could be greater than b or b could be greater than a or whatever it is, because we have to do it optimally, we'll have to kind of group a few prime factors. So the obvious path would be to, for example, keep dividing it. Basically just follow its prime factorization. That's if that's what you are following while bringing n down to 1. So if n was, for example, say 15, so you first, so 15 is equal to 3 into 5, right? So what you can do is first divide 15 by 3, that brings us to 5, then divide 5 by 5, that brings us to 1. So just follow its prime factorization, right? That's a very basic approach. But because odd have some value and even have some value, you may have to group them, right? And another constraint here is that a and b could be negative as well. So in that case, for example, if the points you get on dividing it by an even number, that is a, if is negative whereas b is positive, we'll try to have as many odd factors that we are using to bring it down, right? Because we want to maximize the score, obviously. So let's have a look at the sample. I'll obviously give a detailed approach a bit down the lane. So just take the first sample where the number is 10, and on dividing it by an even number we get 2, and by an odd number we get 3. So we have 5 here. So by 5 is the maximum score. Well, the explanation is given that first divide 10 by 2, right? Because 2 is an even number, we get 2 points. Then divide it by 5. You now get 3 points, right? So chef gets a total of 5 points. Notice the other path would have been to simply divide 10 by 10, right? In that case, because 10 is even, we would have got 2 points. But obviously 5 is the maximum that we can achieve, right? So that's basically the problem. And notice again, because a and b could be negative, the solution is not, the answer is not bound to be positive. Fine. So even if the best he does, he sometimes may have to end up with a negative score. Let's move on to the approach now. That was about the problem. Great. So you know the first thing that we have to do is prime factorize, that I've already explained in the problem, right? And this is a good way to start off, because now we get a hint of how we should approach. So as you can see here, 600 has three even factors, even prime factors. And remember, I'm not talking about the prime factors themselves, I'm talking about their count. So 2 is occurring 3 times. So I can say that 3 even factors are there, and I have 3 odd factors or prime factors. Fine. So this basically means is that the ideal path, okay, the very basic path could be to first divide 600 by 2, right? That brings us to 300. Then divide 300, then divide 300 by 2 again, this factor, right? And this becomes 150 now. Then divided by 2 again, it becomes 75. Then divided by 3, this 3 here, it becomes 25. then divided by 5 it becomes 5, finally divided by 5 it becomes 5, right? So for any number, just follow the path of its prime factorization, and this is one valid solution. But this may not be the optimal always, right? Obviously, because a and b have some value, even and odd have some value. So what we can do is, now is the time to group them. So here comes the casework. So this problem is a casework problem. That is, you have to build 4 different cases on when A is positive and B is positive, A is positive and B is negative, A is negative, B is positive, A is negative, B is negative. So these are all the 4 possible cases. And in positive, I also include 0, right? So what happens is that for the first case, right, when A is positive and B is positive, this in fact is the optimal solution. Why? Because at any step we are getting some score. So in a way to try to maximize the number of steps, we can just keep dividing it by its prime factorization only, the way we saw here. Because if I group 2 and 2, right, so I first divide 600 by 4, right, that would give us 150. So we skipped one step, right? We skipped this step, and because both were positive, right, that was non-optimal. Because had we not grouped them, we would have got a points twice, right? So when both are positive, so you will obviously want to divide it as many number of times as you can and not group any of these numbers. Fine. So that's the first case, the most rudimentary one. Now let's come on to the second case. That is when A is positive. That is when we that is when we try to maximize the number of times we divide it by an even number, because B is negative, right? So this is the second case. And now for this one, it's pretty obvious that we'll leave the even factors independent, right? And the odd factors can be grouped into one big odd factor, right? So 600, right, instead of dividing by 3, then 5, then 5, because that would fetch us a lot of negative points. To avoid that, what we'll simply do is we'll group all these odd into ones, right? That means that we'll directly divide it by 75, right? So instead of 3 steps of 3, then 5, then 5, directly divided by 75. And in fact, that is also not we are going to do, because we can merge this 75 into some even number. So what happens is we can divide 600 by 150. So our basic step is to compress all the odd factors into one large odd factor, right? And then again, we do not need to incur a loss of B points, right? We can again merge that into one even factor, and we all know even into odd is even. So now this would fetch us some positive number of points, right? So the edge case could be when we do not have any even factor, right? Like for example, when it is 105. So this is 3 into 5 into 7, right? So is it? Well, yes, it is. So 105, when there is no even factor, then again we can, just compress it into one big odd factor, that is 105 directly, and then divide 105 by 105, right? But we do get some negative points because we cannot merge this 105 into some negative one. So this is the edge case when there are no even factors, so you cannot merge this large odd factor into this one, right? So you will have to incur a negative loss. But again, it's always optimal to make one big large odd factor out of smaller odd factors. Fine. So this is the second case. If we have a lot of odd factors, just convert it into one, and then if I do have some even factors, then just merge one of them into that. So in this case, we'll just get a into number of even factors that we have, right? If there are some even, otherwise obviously we'll we are just dividing it by 75 in this case, right? Or in this case 105. So that would be one time loss of b, one time b points, right? So that would be b. Otherwise, if we do have even numbers, just merge this big one into one of them, and then divided by 2, divided by 2, divided by 2 into this huge segment, right? So that would be even number of even factors it has times the points we get for one even factor, that is a. Right. So for the first one, it's obviously a into even, right, plus b into odd, right? So that's pretty basic. That's the prime factorization only. For every even factor, we'll get a. For every odd factor, we'll get b. Since both are positive, this is always optimal, right? In this case, for the second case, right, we can, if I have an even factor right? Then just merge all the odd factors into it. The result is again even, and then you have a even numbers, right? In one of them you have merged all the odd ones, so you have a into even, right? That's the best you can get. And if I do not have any even, well, in that case, just take all the odd factors, right? You basically don't have any even factor to merge them into, so you just take all the odd factors, divide it at once, like 105 divided by 105, and you do get the points, which is negative, but always is optimal, right? So now let's come on to the third case when A is negative, B is positive, which implies that we want to maximize the number of odd factors that we divided with. Okay, so this is the third case. So this time, like very similar approach to the previous one, is that this time we'll try to merge the even factors. Fine, so 2 into 2 into 2 in case of 600, we can merge them into 8, right? And then what we can do is we can just divide 600 by 8, right? And that would be one time gaining a points, which is negative, but only once, right? And then just keep dividing it by all the odd factors one by one, because b is positive, we'll divide it one by one. So this time it's obvious that if it does have even factors, then it would be a. So it's obvious that the number of odd factors it has that are odd, right? Let's store them in a variable name odd, and that into b, that's obviously what we can get. And if it does have some even factor, right, at least one even factor, we are anyways merging them into one, so that would be a points as well, if it does have, right? So that was the third case, right? So as you can observe that this problem is casework based, and the hard part about it is that casework problems are often torturous. You need to pay very close heed to it, otherwise you may mess up a few cases. And don't be afraid to put in a lot of if conditions, because that way your program will just become more robust. If you try to think that, oh, there are so many cases, let me write a cleaner approach to this, in that case you may miss few of them, and then just cry to your fate that you got a wrong answer. Fine. So best to just explicitly list down most of the cases, right? And then think carefully exactly what will happen, right? Because these are four cases. On top of that, we also have case if there is a negative. So if there is an even factor, if there is an odd factor, how can we merge them and all? So there are cases, but don't be afraid to write all of them, right? And even if you feel that this is getting a bit too complex, well, that is again because there are a lot of cases, right? So you may not understand this kind of a thought process, but I have just given you a great head start that first take all these four possible cases, then consider that because something is negative, we'll try to shift ourselves to just try to do the positive one. So for example, in the second case, you can see that a is positive, so try to maximize the number of times we divided by an even number. And because b is negative, just merge all the odd numbers, and if you have an even factor, merge all of them into some even factor, right? So that's basically your thought process. Don't mug up these equations, right? Just try to understand what's happening, and even if it feels a bit complex, you should get what I'm doing, right? Not exactly the nitty-gritties and all, but the basic approach. So you can code it out yourself as well if you understand it well. When a is negative, b is negative, the fourth case is left. So I want you to think about it yourself, right? You can pause the video here if you wish. Great. So when both are negative, it's obvious that any division that we do is just, bringing us to a even more negative score. So we'll just merge all these up. Fine. Just take all these factors, merge them into one, and what will be the resulting factors parity? Well, if we had one or at least one even factor, well, after merging them, right, we'll have an even result. If all of them are odd factors, like in case of 105, when we multiply all these, the result still comes out to be odd. So based on that, our score will be A or our score will be B. So these are all the four cases. Let me quickly move on to the C++ implementation. Although, note, Python users don't curse me, Java users don't curse me. I'm just showing you a C++ implementation, right? The reason is it's most popular, and in this problem specifically, all the implementations are very similar. So if it was a more of a DS algo based kind of approach, I would have definitely shown you implementation in all languages, right? But this time it's it's literally identical in all languages. So I'm just showing in one. I'll post the implementation in Python in comments, right? So as a pinned comment, you can refer to it. But don't just think that hey, he's explaining in C++. I only know Python, so just leave. Right? That's not the ideal spirit. So I'm just moving on to the code. I'll keep explaining it in pseudocode-ish terms, so you know what's happening. So this is like a main function that is, I am just taking the input for test cases here and running some function solve test cases number of times. Fine. So I start with taking the input for n, a, b, the number initially. Then a is the score you will get on dividing it by even number. B is the score on dividing by an odd number. Then I calculate the even and odd, right? The count of the even and odd prime factors. So here I start off with 2, I go until square root of n. Now this is a prerequisite. I have created a video on it, you can watch it, right? And this is actually very important. The only thing we are modifying here is that we don't want the prime factors themselves. So while n modulo I is equal to 0, I keep dividing it, and if I was even, then even, otherwise odd, I increment its count. Right, so exactly like if I take 600, then even would store 3 and odd would store 3 as well. Now this is also another condition that is associated with prime factorization only. So again we have to take care of if n is still greater than 1. So after this we have the count, right? This is one group of code that helps us find this. And finally, based on 4 cases, I have 4 different solutions. Let me quickly touch upon them as well. If both are positive, right, I say that answer is equal to even into a, divide it as many number of times. In fact, just follow its prime factorization only. That is, you have even number of factors, each fetches you a points, plus odd number of factors, each fetches you b points. If a is positive and b is negative though, right, try to maximize the number of even numbers you have, right, even divisions you do. So you say that all evens would be separate, and if there is no even factor, right, then after merging all the odd into one big odd factor, you don't have any even factor to merge them into, right? So if even you do have some even factors, then obviously just merge all the odd factors into some even factor, right? And you have a even factors, each of them will give you even. You have even number of factors, each gives you a point, so you have this is the score. If all the factors are odd, like in case of 105, right, just merge all of them into one big odd factor, and one division of any odd number will give you b points. Similarly, if a is negative, b is positive, you can obviously divide them all of them by b number of times, right? Odd number of times, and get b points for each. So this is the obvious goal. Now, if you do have some even numbers, right, in that case you have to get a more points, right, by merging all the even numbers into one big even number. That division will give you a points. Otherwise, if you do not have any even number, then just zero. Finally, if both are negative, then just because any division is just making you go even down and down into more negative score, so you will just try to have one division, just merge all these factors into one. If that would be even, right, so if you have an even factor, then the product of all those would be even. So you say that in that case you will get a, otherwise you will get b the score. Print out the answer. So I get 5 minus 2 7 minus 1. That seems correct. So let's quickly submit the code. Right, so I have already pasted it. Now let's hit the submit button and hope for an AC. And remember, you can always ask me your doubts in the comment section, and like the video if you like the explanation, and I'll be keen to reply to them, so don't hesitate. And you can always find the link to the code in C++, and I'll try to put on Python as well in that as a pinned comment. Great, so we do get it accepted, guys. So yep, this wraps up the video. This is Bharat Singla from CodeChef signing off, and chalo bye.